Alright, today we're going to do law of sines in this video and the next video. Law of sines is going to go on page 120 today, 121 in the next video. So 14.1 law of sines. This is going to be the trig when you don't have a right triangle, okay? So go ahead and turn to page 120. We're going to label that 14.1 law of sines. And then we're going to get started on the foldable that is in your this attached to this video. So go ahead and grab that, and we're going to start talking about that. This one, fold it so that you've got the law of sines shown, and let's go ahead and get started on that one.
So the law of sines proportion says that you have a side length A over the sine of the angle across. Something that bothers me about this that I didn't notice until just now is that you use small letters to denote side lengths, not small, lowercase letters for side lengths, uppercase letters for angles. So we need to change all these to uppercase. Not that you can really tell with the C. So those go together. Then this side length B over the sine of its angle, opposite angle. And the side length C, which corresponds with the sine of C and its opposite angle. Now, in order for you to be able to use the law of sine, you obviously only have to have two of these going on, not all three. Law of sines, as you can see at the bottom of this, can be used to solve triangles where we know two angles and a side. So either angle, angle, side, or angle, side, angle. Or if you are given two sides and a non-included angle. You have to be careful here. Do you know why you have to be careful here? What is that? Is that a triangle congruence? It's like hypotenuse leg. We are going to talk about, that's called the ambiguous case of law of sines. Sometimes it's going to work, sometimes it's going to not, sometimes it's going to have two answers. Two answers. Yeah. Sometimes it's going to have two. So we'll look at that in a minute. We're going to focus on these two at first. So anytime you have angle, angle, side, or angle, side, angle, law of sines is going to work. So we're going to open our foldable and twist it around and see that. Okay. Example 1. Given two angles and a side, so we have angle, angle, side, we are going to solve this triangle. When it says solve the triangle, it means we want every piece that is missing to be found. It says first, find the third angle. You know how to do that without even the law of sines. So let's find angle A. How do we find the measure of angle A? Yeah, 180 minus 107 minus 25. Somebody told it to me. What is it? 48 degrees. All right, that's the first thing we're going to do. 48 degrees. Great. I'm having a problem making it so you can see it today. Alright, so next it says find the sides using the law of sines. We need to find A and we need to find C. I'm just going to go in alphabetical order. You're going to find A first. That means if I need to find A, I'm going to use this because it is opposite to the side length A. That 48 degrees is opposite to the side length A. What is the only other side length we know? B. And it corresponds with what? Angle B, which is 25. That's what we're going to use to find A then. Zoom in on that a little bit. Okay, so looking at our law of sines proportion, I have A, which we don't know what is. Zoom back out. A over the sine of A, but what is A? The angle A is 48 degrees, equals B, what is the segment B? Over the sine of B. What is the angle B? That is how I set up law of sines. I'm then going to cross multiply. I'm not going to round till the very end. I don't think it tells me what to round to. If it does not tell you, I want you to do 4 decimal places, even though you might think that seems like a lot. Do it anyway. Alright, I'm going to cross multiply. So A times sine of 25 equals 15 times sine of 48. You do not need to type anything in until you get A by itself. Divide by the sine of 25. So A equals 15 sine of 48 over, or divided by, sine of 25. Type that in, get A to the nearest 10,000, which is, 4 decimal places. Make sure it's in degree mode. 4 decimal places. You got what, 26? Somebody get anything different? I got 13.7477797. Oh yeah, you see this? I didn't close the parentheses. People do that all the time and get the wrong answer. You're right. I just wanted to show you that I see that all the time. If you put it all in at once and don't close that parenthesis, you're going to have a problem. Okay. So just be careful. 26.3765 is correct. That's correct. So you're typing in this. If you didn't get that, make sure you put the parentheses where they go. Or your calculator's in degree mode. We're going to do another one. I'll make sure that you've got another. We're going to keep going. We're going to use this one to solve for C now. Something that is nice when I keep doing these over again, I've got to find C now, but no matter what, I'm going to take what I know from this proportion. I knew that I had 15 over sine of 25. That's the B side and angle. I'm now going to set up the other part with C. So I don't know C, but what is its angle measure? So sine 107. Now that that's set up, I want you guys to cross multiply and find C. Okay, you cross multiplied. And when you cross multiplied, what did you have? C times the sine of 25 equals 15 times the sine of 107. Okay, and then what'd you do? What was C equal to? Because I'm not going to write that back down again. You don't have to after that step. 33, not 30. 33. So you typed this in your calculator. C is the longest side length because it's across from the longest angle. Did it work out that way with our value here? Is that the longest side? It did. We're good. If you have angle, angle, side, or angle, side, angle, they all work out this way. You do have to, when it says solve the triangle, find every single piece. Okay? Alright, we're going to move it to example 2. Go ahead and find the third angle. What's missing? I'm talking about the angle. We got to find the angle first. Find the missing angle. It's what? 35? Alright, now what sides are missing? So find B, find C, using the fact that the angle A is 35 degrees. You're going to match up side length over the sine of the angle. Side length over the sine of the angle. I want you to set them up. Try us all those. Okay, so we have A. So you said 30 over sine 35, which is what we're going to use for all of them. We're also going to use that for C. Do you know why we use that one again for C instead of using B? It's not a decimal, it's not rounded. So we always go back to the one we had originally. Okay? So B then is B over sine of what? While I'm at it, let's set this one up too. It's C over sine of... Okay. Cross multiply, and you get 30 sine 30 equals B sine 35. Then what'd you do? And you plugged this in your calculator, correct? Okay, so what was B equal to? What? Okay. We don't have units. If we did, I would want you to put them, but we don't have any. Alright, similarly here, we're going to cross multiply, but you get 30 sine of 115 equals C sine of 35. Divide by sine of 35. Of course, that crossed out here. And you are plugging this in. What did you get for C when you plugged that in your calculator? I hope that's what you said. 47.4030. Okay. Alright, we are going to talk about the ambiguous case next. You need to open your notebook and glue this in. But before you do, we have skipped 13.4. But we are going to come back and do 13.4. It will take us less than half a day to do it, and that's why I'm skipping it for now, because we're going to do it and take your quiz on Friday. So, we are skipping 2 pages until Friday. So that means this goes glued on page 116. Glue this on 116.
Okay, now that we have finished the examples for the law of sines, we're going to go ahead and glue this in on page 120. We'll have to glue it in sideways, but there's the law of sines. We will finish talking about the law of sines tomorrow in something called an ambiguous case, but go ahead and glue that in, glue it to page 120, and tomorrow we'll work on 121.